solve the following Bernoulli's differential equation. So we have this equation dy over dx plus, we can read like 1 over x times y equals x y raised to negative 1. If we did not have this, let's say, now then this is linear in y with respect to x, right? Dy over dx plus 1 over x y equals x. It's linear, but because of that it's non-linear, but just one factor. So we should be able to solve. The goal here is to convert this non-linear Bernoulli's differential equation into a linear one. After we get a linear differential equation, we find an integrating factor and go from there. So first off, we want to divide by, we want to get rid of y raised to negative 1. So divide both sides by y to the negative 1. Y to the negative 1 means 1 over y. So divide by 1 over y means same as multiply by y. Multiply through by y, then we get y dy over dx plus, I'm going to write 1 over x, y times y square equals x. Okay. Now right hand side is good. Okay, but we make a substitution so that this converts into a linear. So here y square, let's say that is v. Okay, so let v be y square. Now we want to find dy over dx. For we find derivatives of both sides with respect to x. Then dv over dx, derivative with respect to x is 2y times from the chain rule dy over dx. Now divide by 2y, so 1 over 2y dv over dx equals dy over dx. Okay, so let's say this one is star. Now with this substitution, okay, then the ODE star becomes y is y, dy over dx we just found here, that's 1 over 2y dv over dx plus 1 over x, and we assume that to be v equals x. Now y should be gone, okay, y cancel, okay, it should be a linear. So 1 over 2 dv over dx plus 1 over x v equals x. Yeah, this is a linear in v with respect to x. Now we want to solve this. First 1 over 2, let's get rid of this. So multiply through by 2, we get dv over dx 2 over x v equals 2x. Okay, we multiplied through by 2. So linear in v. Okay, that means, let me call this one double star. Now we find an integrating factor, and this one is our p to find the integrating factor. In fact, an integrating factor. Okay, so integrating factor, let me use the same color. Mu x is e raised to integral of that 2 over x dx. E raised to 2 can be pulled outside, 1 over x dx. Antiderivative of 1 over x is natural log of absolute x. But x is given positive, so absolute value not needed. This 2 goes there, so this one e ln x is squared, then e and natural log cancel, so simply x is squared. Okay, so an integrating factor is x squared. Now we multiply double star by integrating factor. So after we have an integrating factor, we multiply through by x squared. That makes the left hand side automatically derivative of dependent variable, which is v times integrating factor equals right hand side 2x times x cubed, x squared, so 2x cubed. So when we multiply through left hand side from these two terms, automatically we get this one, right hand side 2x cubed. Now integrate both sides with respect to x. when we integrate, we get v times x squared, integrate this 2x 4 over 4 plus c. Okay, now we can isolate v, so divide both sides by x squared, so v equals dividing by x squared, right? 2 goes for 2 times, so this number is 1/2. Dividing by x squared means x squared plus c over x squared. Okay, done. But v was not in the question, so we need to replace v, which is y squared. So that is y squared equals 1/2 x squared plus c over x squared. And if you want to find y, square root of this one. Okay, y is, which is not needed, but it's so simple, let me put plus or minus of this junk, which is 1/2 x squared plus c over x squared.